In the early 19th century, Danish scientist Hans Christian Ørsted performed an electric experiment and accidentally left a compass nearby. When Ørsted noticed that the electric current caused a movement of the compass needle, he researched further and discovered that a steady electric current generates a magnetic force. Today, we think of this force as a magnetic field around the wire. We show this field as a set of vectors encircling the wire to indicate both the direction of the force and its strength. Not long after Ørsted's discovery, the English scientist William Faraday reasoned that if a steady electric current creates a magnetic field around a wire, then a steady force from a magnet might in turn be shown to create an electric current. By 1831, when Faraday set out to test his theory, it was known that a wire wound into a coil, or helix, strengthened the magnetic force produced by an electric current in the wire. It was also known that an iron core within a helix would further intensify the field. Faraday wanted as strong a magnetic force as possible to help him demonstrate that it could induce an electric current. He attached a battery to a wire wound in a helix around an iron ring to create an electromagnet. In order to induce electricity, he established a separate circuit, winding another wire around the core, but attaching it not to a battery, but to a galvanometer, which would detect the presence of a current. When Faraday closed a switch to power up his electromagnet, for the briefest moment it looked as if his prediction was correct. The galvanometer indeed did show a flow of electricity through the second circuit, a flow that could only have been induced by the magnetic field of his electromagnet. But the galvanometer registered the current only for a brief moment, before showing once again that no current flowed through the circuit. Even more puzzling, as the electromagnet was turned off, there was another brief spike of electric current through the second circuit, one which immediately fell again to zero. What was going on here? Faraday was supplying a steady flow of electricity to the electromagnet, and therefore producing a steady magnetic field. But the result was only the briefest indication of an induced electric current in the second circuit, and then only as the electromagnet was being turned on and off.